It had the face of the future and the soul of a catastrophe. Lines so clean and sharp they looked drawn by an architect rather than an engineer. A nose that split the air like a blade. A body that seemed to stretch beyond what was physically possible. When it sat still on the platform, people did not look at it the way they looked at other trains. They stared. They went silent. Some of them, without quite knowing why, felt something close to fear. This was the Pennsylvania Railroad T1, and it was going to save American steam. At least, that was the plan. What actually happened was something far more complicated, far more human, and in many ways, far more fascinating than any simple success story could ever be. Because the T1 did not just fail. It failed in ways that nobody predicted, in ways that baffled the engineers who built it, in ways that made seasoned railroaders question everything they thought they understood about machines and speed and the nature of ambition itself. It failed beautifully, brilliantly, completely. And understanding how and why it failed tells you something important not just about locomotives, but about what happens when human beings refuse to accept that a dream might be impossible. When pride, genius, and sheer stubbornness collide with physics at 120 miles an hour on a steel rail in the middle of Ohio. To understand what the T1 was, you first have to understand what it was trying to replace. And to understand that, you have to stand for a moment in America in 1940 and see the world through the eyes of the men who ran the railroads. The Pennsylvania Railroad was not just a company. It was, for a very long time, the most powerful transportation organization on the planet. They did not call themselves a railroad. They called themselves the standard railroad of the world, and they meant it without a trace of irony. Their main line between New York and Chicago was among the busiest, most profitable stretches of track ever laid. Thousands of passengers every single day, millions of tons of freight every single year. A river of commerce moving east and west across the spine of a continent. To move all of that, the Pennsylvania Railroad needed locomotives. And for decades, it had built some of the finest locomotives that American engineering could produce. Big, reliable, powerful machines that understood their job and did it without complaint. But by 1940, a quiet alarm had begun to sound in the offices of Altoona, Pennsylvania, where the railroad's engineering staff worked. The alarm was not loud yet, but it was persistent, and the men who heard it knew that if they did not answer it soon, the consequences would be severe. The alarm had a single source, a single word that kept appearing in cost analysis reports, maintenance schedules, and operational reviews. The word was diesel. The diesel-electric locomotive was not a new idea in 1940. General Motors had been developing it for years. The technology was already working in passenger service on smaller railroads. And what made it terrifying to the steam engineers at the Pennsylvania Railroad was not its power, which was modest by steam standards, but its economy. A diesel could be started with the turn of a key. It did not need a fire crew showing up 2 hours early to raise steam pressure. It did not need a water supply every 100 miles. It did not need a fireman shoveling coal by hand during every mile of every journey. It could be driven from either end without turning around. It could sit idle for days and start again without drama. Every one of those advantages translated directly into money. Less labor, less fuel, less maintenance downtime, less infrastructure. And money, in the end, was the language that decided the future of every locomotive ever built. The engineers at the Pennsylvania Railroad looked at those numbers and felt something deeply uncomfortable. Because what the numbers were quietly suggesting was that the golden age of steam, the era that had built their careers, their reputations, their entire understanding of what a railroad was, might be coming to an end. They were not ready to accept that. What they decided to do instead was something audacious, something that, depending on how you look at it, was either an act of extraordinary engineering courage or an act of extraordinary engineering denial. They decided to build a steam locomotive so advanced, so powerful, so spectacularly fast and efficient that it would make the diesel irrelevant before it even had a chance to prove itself. They would not retreat from steam, they would attack. The man they turned to was Raymond Loewy. If you have never heard that name in the context of locomotives, you may know it in another context. Loewy was the greatest industrial designer America has ever produced. He designed the Coca-Cola bottle, the Lucky Strike cigarette package, the Studebaker Avanti, the interior of the NASA Skylab space station. He had an instinct for the future so precise it seemed almost supernatural. And when the Pennsylvania Railroad brought him in to shape the exterior of their new locomotive, he delivered something that nobody on the engineering team was fully prepared for. The T1 was unlike anything that had ever moved on rails. Other streamlined locomotives of the era had rounded noses and smooth flanks, designed to suggest speed while still looking recognizably like trains. The T1 had something different. A sharply angular nose that divided at the front into two distinct planes, like the prow of a warship cutting through water. A horizontal band of chrome trim along the body that seemed to pin the whole machine to the ground. Running boards that swept in clean geometric lines from nose to cab. And above all, a visual coherence, a sense that every single element of the exterior had been considered and placed exactly where it needed to be, and nowhere else. Railroad workers who saw it for the first time stopped what they were doing. Passengers waiting on platforms felt the hair rise on their arms. Photographers who came to document the first prototype found themselves shooting roll after roll of film, unable to capture something that seemed to look different from every angle, and yet perfect from all of them. But Loewy's exterior was only the packaging. Inside that extraordinary shell, the Pennsylvania Railroad's own engineers had been working on something technically remarkable. Something that, on paper, represented a genuine leap forward in the science of steam locomotion. Something called the duplex drive. The concept behind the duplex was elegant in its logic and ferocious in its implications. A conventional steam locomotive had a single set of driving wheels, all powered by the same pair of cylinders. The T1 would have two sets of driving wheels, each powered by its own dedicated pair of cylinders. 4 cylinders in total, 2 at the front of the locomotive, 2 at the rear. Each pair working its own set of drivers, completely independently. The reasoning was this: a locomotive's power is limited not just by its boiler, but by the size of the cylinders that convert steam into motion. Bigger cylinders mean more power, but bigger cylinders also mean bigger pistons moving at higher speeds, which means more violent mechanical forces, which means more vibration, more wear, and more catastrophic failure when things go wrong. The duplex approach solved this by splitting the power output between 2 smaller pairs of cylinders. You got the total power you needed without building any single component to an extreme that the materials could not tolerate. On paper, the T1 would be the fastest, most powerful passenger steam locomotive America had ever seen. A machine that could haul a full passenger express at sustained speeds that diesels could only dream about. A machine that would make the question of steam versus diesel seem like an old argument that the future had already answered. The prototype, numbered 6110, rolled out of Altoona in 1942. And the first time it moved under its own power, every person who watched it knew they were looking at something they would remember for the rest of their lives. What they did not know because they could not yet know, was exactly how complicated the next few years were about to become.
The trials were remarkable. In almost every way that could be measured, the T1 performed exactly as its designers had promised. Its speed was extraordinary. Test runs on the Pennsylvania main line showed the locomotive capable of sustained high-speed running that no previous steam design could match. Dynamometer tests recorded power outputs that made engineers blink and check their instruments twice. The boiler produced steam at rates that fed all 4 cylinders without strain. The exhaust note, a rapid mechanical bark unlike anything else on the railroad, became instantly recognizable to every crew that worked with it. The Pennsylvania Railroad was sufficiently impressed that it ordered a production run. Not 1 or 2 test units, but 50 locomotives. 25 to be built by the Baldwin Locomotive Works. 25 to be built in the railroad's own Altoona shops. It was a declaration of confidence that echoed through the entire industry. Steam was not dead. Steam had just found its future. But even in those early triumphant months, something was there, hiding in the test data like a shadow at the edge of a photograph. Something that the engineers noticed, recorded in their reports, discussed in their technical meetings, and then, for a variety of reasons that all added up to the same thing, did not fully solve. The T1 had a problem with its wheels. At high speed, under certain conditions of acceleration and track quality, the driving wheels of the T1 would lose their grip on the rail. Not dramatically, not catastrophically. Just a fraction of a second. Just a slight, almost imperceptible slipping of steel on steel. And when it happened on the front pair of drivers, it sent a ripple of mechanical imbalance back through the locomotive to the rear pair, which was still gripping, still pulling, and which suddenly found itself dealing with forces it was not designed to handle. The result was a phenomenon that railroaders called wheel slip. And in the T1, wheel slip was not just an inconvenience. It was the beginning of a chain reaction that the locomotive's entire mechanical system had no good way to interrupt. When the front drivers slipped, they spun faster than the rear drivers. For a fraction of a second, the locomotive's 4 cylinders were delivering power at mismatched rates to drivers moving at mismatched speeds. The resulting forces rippled through the running gear. Connecting rods vibrated. Crank pins hammered against their bearings. The locomotive shook with a violence that could be felt on the footplate as a sensation somewhere between a heavy punch and an electrical shock. Experienced crews described it as the locomotive trying to tear itself apart from the inside. On its own, a single episode of wheel slip was recoverable. The driver could close the throttle, let the wheels regain their grip, and begin again. On the T1, this happened so frequently, so suddenly, and with so little warning that managing it became a constant, exhausting, nerve-shredding preoccupation. Running a T1 at speed was not like running any other locomotive. It required a level of attention and physical skill that pushed human beings close to their limits. The throttle had to be managed with a precision that was closer to surgery than to driving. Open it too quickly, and the front drivers spun. Open it too slowly, and you fell behind schedule on a railroad that did not tolerate delays. The sweet spot between those two extremes was narrow, and on a cold rail, or a wet rail, or a rail dusted with the first frozen dew of an autumn morning, that sweet spot could vanish entirely without warning. The railroad tried everything. Sanding gear, which sprayed fine sand between wheel and rail to improve grip. Different boiler management techniques. Different approaches to cylinder lubrication. Different valve settings. Different crew training programs. One by one, each potential solution was tried. And one by one, each potential solution was found to help somewhat, but not enough. The wheel slip problem did not disappear. It could be managed, minimized, worked around by the most skilled and experienced engineers on the roster. But it could not be eliminated. And that distinction between a problem that could be lived with and a problem that could be solved was about to matter enormously. Because meanwhile, quietly and without fanfare, General Motors was making the diesel better. Every year that passed saw another generation of diesel-electric units roll out of the LaGrange, Illinois assembly plant. Slightly more powerful than the last, slightly more reliable, slightly more economical. The gap between what diesel could do and what steam could do was closing with a mathematical relentlessness that no amount of engineering heroism could reverse. The Pennsylvania Railroad's management watched this process with growing unease. They had invested enormous resources in the T1, 50 locomotives, training programs, shop modifications, spare parts inventories. The political and professional capital of an entire generation of senior engineers who had staked their reputations on the assertion that steam had a future. None of that could be easily abandoned. But the ledger sheets told a story that reputations could not argue with. The T1, when it ran well, was magnificent. There are verified records of T1 locomotives maintaining speeds of well over 100 miles an hour for sustained periods on level track. There are crew accounts of runs where the locomotive felt like a living thing beneath their feet, responsive and surging and almost impossibly fast. A machine that seemed to understand what it was and wanted to demonstrate it. On those days, on those runs, the T1 was everything its designers had promised. But those days were not every day. The maintenance records from the Pennsylvania Railroad's locomotive shops tell a different story. The T1's availability rate, the percentage of time a locomotive was actually in service rather than in the repair shop, was consistently lower than the railroad's older steam designs. Not dramatically lower, not catastrophically lower, but lower in a way that accumulated over weeks and months into thousands of revenue ton miles lost, into schedules that could not be reliably met, into passengers who booked on competing railroads after one too many announced delays. The wheel slip problem consumed enormous amounts of maintenance time. The violent mechanical stresses it generated were not just unpleasant for the crew. They were destroying the locomotive from the inside. Connecting rod bearings wore at rates that required replacement far more frequently than on conventional designs. Crank pins developed flat spots that degraded ride quality and drove further mechanical deterioration. Valve gear, subjected to forces it had not been designed to handle, required constant adjustment. Every maintenance crew that worked on the T1s developed a specialized knowledge of their particular locomotives, an intimate familiarity with which machine had which tendency and what it would tolerate on any given day. That kind of knowledge was valuable. It was also, from a railroad management perspective, terrifying. Because it meant that the T1 was not a machine. It was a relationship. A complicated, demanding, expensive relationship that required skilled and experienced human beings to sustain it. Remove those people, and the machine did not simply become less effective, it became dangerous. The diesel did not require a relationship. A diesel unit could be driven by a man who had trained on it for a fraction of the time it took to develop the kind of feel for a T1 that its best crews carried in their hands. A diesel unit did not have a bad day in cold weather. A diesel unit did not develop individual mechanical personalities that required specialist knowledge to manage. A diesel unit was, in the most fundamental sense, a tool, reliable, predictable, interchangeable. The T1 was something more than a tool. It was also something considerably more expensive to operate than one. There was a moment, sometime in the late 1940s, when the people who made the Pennsylvania Railroad's decisions looked at all of these facts laid out together and understood what they meant. Not with the dramatic shock of sudden revelation, but with the slow, reluctant, utterly final recognition that comes when you have been avoiding a conclusion for long enough that avoiding it any further requires more effort than accepting it. Steam was over. Not just the T1, not just the duplex concept, not just the Pennsylvania Railroad's particular approach to the problem of high-speed passenger traction, all of it, the entire tradition. The century and a half of accumulated knowledge and craft and human identity that had been built around the steam locomotive. Over. The diesel order that followed was not issued with any ceremony. There were no press releases celebrating a historic transition. There were no speeches honoring the end of an era. The paperwork was filed, the contracts were signed, and the T1s began their retirement with the same quiet efficiency that characterized all corporate decisions about machinery that had outlived its usefulness. It took barely a decade. The last T1 in regular service was withdrawn somewhere around 1956. Some of them did not even last that long. The newest of them, built in the late 1940s with all the lessons of the prototype program incorporated into their design, were retired with fewer than 10 years of service behind them. Machines that had cost a fortune to design and build, that had been intended to define the future of American steam for generations, were cut up for scrap before they had even reached middle age. Not one of them was preserved. In the entire production run of 50 T1 locomotives, not a single example was saved by a museum, a historical society, or a private collector with the resources and determination to hold one back from the scrapper's torch. The most beautiful locomotive ever built in America, the machine that Loewy had shaped into something that looked less like engineering and more like art, disappeared completely. What remains are photographs, technical drawings, maintenance records, and the recollections of the men who ran them. The silence that replaced them was not dramatic. It was simply the silence of machinery that has gone, which is the most final kind of silence there is. But that silence is not the end of the story. Not really. Because the T1, in failing, left behind something that neither its designers nor its operators ever quite intended to create. It left behind a mystery. Because the wheel slip problem, the fundamental flaw that undermined the T1's operational career and contributed directly to its early retirement, was never fully explained during the locomotive's working life. The Pennsylvania Railroad's engineers had theories. They had data. They had maintenance records thick enough to fill filing cabinets. But they did not have a clear, definitive technical understanding of exactly why the T1's front drivers were so prone to losing their grip, and why the mechanical consequences of that loss were so violently amplified through the duplex drive system. That mystery survived the scrapping of the last locomotive. It survived the dissolution of the Pennsylvania Railroad itself, which merged with the New York Central in 1968 and eventually collapsed into bankruptcy in one of the largest corporate failures in American history. It survived in the technical literature, occasionally surfacing in engineering journals and railroad history publications, and online forums where people who cared deeply about such things argued about it with an intensity that seemed disproportionate to anything with practical consequences in the modern world. But perhaps the proportions were exactly right, because what those arguments were really about was not wheel slip coefficients or valve gear geometry or boiler pressure calculations. They were about a question that has no purely technical answer. Did the T1 fail because it was a bad design? Or did it fail because the world changed around it before it had time to be fixed? There are serious, knowledgeable people on both sides of that argument. Those who believe that the wheel slip problem was fundamental, not merely a developmental challenge, but a genuine structural flaw in the duplex concept that would have required rebuilding the locomotive from the ground up to resolve. And those who believe that with modern understanding of tribology and adhesion physics, with better sanders and more sophisticated wheel slip control systems, a T1 could have been made to work reliably and consistently at everything it was designed to do. The argument will never be fully resolved, because the machines are gone. Unless, in 2014, a group of engineers and railroaders and people who simply refused to accept that the T1 should be forgotten formed an organization with a goal that sounded, to most people who heard it, somewhere between deeply ambitious and completely insane. They called it the T1 Trust. and their stated purpose was to build a new Pennsylvania Railroad T1 from scratch, using original drawings where they existed, modern engineering where they did not, and a combination of private funding and sheer collective determination to see whether a 70-year-old question could finally be answered. The project was not small, reconstructing a locomotive of the T1's complexity using a combination of surviving original documentation and modern manufacturing processes required solving problems in metallurgy, machining, boiler design, and mechanical engineering simultaneously, while also managing the logistics of a large-scale collaborative project involving specialists scattered across multiple countries and an engineering heritage that had to be reconstructed almost from zero. The wheel slip problem sat at the center of everything. Because building a new T1 without addressing it would simply recreate the original failure, and addressing it required understanding it, which required going back to the physics with tools that did not exist when the original T1s were designed. What modern tribology, the science of friction and wear between surfaces, understands about wheel and rail adhesion is significantly more sophisticated than what the Pennsylvania Railroad's engineers had available in the 1940s. The interaction between steel wheel and steel rail is not simply a question of weight and friction coefficient. It involves the microgeometry of the contact patch, the behavior of the oxide layer that forms on rail surfaces, the elastic deformation of both wheel and rail under load, the dynamic response of the mechanical system to small perturbations in the contact forces. Understanding these factors well enough to design a locomotive that behaves predictably at very high speeds requires computational tools that simply did not exist when the T1 was conceived. The T1 Trust's engineers had those tools, and when they applied them to the T1's running gear, what they found was illuminating. The wheel slip problem was real, but it was not, or so they concluded, insoluble. It was the product of specific design choices that could have been made differently if the designers had understood what the Trust's analysis was now showing them. The cylinder arrangement, the distribution of valve events across the 4 cylinders, and their interaction with the adhesion forces at the wheel rail contact, the suspension geometry and its response to track irregularities at speed. None of these were simple fixes. All of them were understandable. And if you could build the locomotive again, incorporating what you now knew, the result would be something that the original T1 was always supposed to be: fast, powerful, and stable. Whether that locomotive will ever actually run is a question that depends on funding timelines and manufacturing partnerships, and the 100 practical complications that stand between an engineering drawing and a finished machine. But the project continues, and somewhere in Britain, in workshops that have quietly become the center of the most ambitious steam locomotive construction project of the modern era, components are being manufactured to tolerances that the Baldwin Locomotive Works could never have achieved. A boiler that will produce steam at pressures the original T1's builders would have found astonishing. Running gear designed with the benefit of everything that 7 decades of adhesion physics research has produced. The T1, if it runs, will be neither a reproduction nor a restoration. It will be something stranger and more interesting: a resolution. The answer to a question that was asked 70 years ago by men who died without hearing it. A demonstration of whether the most beautiful locomotive ever built was also fundamentally flawed, or whether it was simply born into a world that was not quite ready to understand it. That question matters more than it might seem to. Because the T1's story is not really about wheel slip or duplex drive or the economics of steam versus diesel in post-war America. It is about what happens when human beings build something extraordinary and it fails. And the answer that the T1 story suggests is not the simple one. Not failure and regret and the end of a dream. The answer is something more complicated, more honest. The engineers who designed the T1 were not wrong to try. They were not wrong to believe that steam had more to give. They were not wrong to push the technology to its absolute limit in a moment when the alternative was to watch everything they had built their professional lives around be replaced by something simpler and cheaper. They were wrong in specific technical ways that, with hindsight, can be identified and corrected. But the impulse that drove them, the refusal to accept limits, the determination to solve the problem rather than abandon the dream, that impulse was not a mistake. It was, in fact, the same impulse that built the railroads in the first place. That laid tracks across mountains that engineers said were impassable and through deserts that geographers said were uncrossable. That built the Big Boy and the Allegheny, and the Mallard and the Class 25 condensing locomotive, and the Camelback and the Garrett. That turned the impossible into the ordinary, one calculated risk at a time. The T1 failed to save steam. But steam did not need saving. It had already done what it came to do. It had moved a civilization from one century to another. It had connected continents and fed cities and carried armies and carried families and carried the raw materials of the industrial world from the places where they were dug out of the earth to the places where they were turned into everything else. It had done all of that over a century and a half. And then it had done it at 100 miles an hour with Raymond Loewy's chrome stripe gleaming in the afternoon light of an Ohio valley. That was enough. That was more than enough. The T1 was the last great argument that steam made in its own defense. And even though it lost the argument, it made it beautifully. It made it with style and intelligence and a mechanical ambition that nobody who saw it in motion ever entirely forgot. When the T1 Trust's new locomotive finally runs, if it runs, it will not bring back the era that produced the original. That era is gone, completely and permanently, and nothing built in a modern workshop will recover it. What it will do is answer the question that the era left open. It will determine, finally and definitively, whether the most beautiful failure in the history of American railroading was a failure at all, or whether it was simply a success that arrived half a century too late. Either way, the answer will be worth knowing, because some questions are important enough that they deserve an answer, even when answering them requires building something extraordinary, even when it requires the kind of stubbornness and ambition and refusal to accept the verdict of history that, in the end, has always been what separates the machines that changed the world from the machines that merely moved through it. The T1 moved through it at 120 miles an hour, and it looked, for that brief, burning, irretrievable moment, exactly like the future. The fact that the future turned out to be something else entirely does not make the moment less true. It just makes it rarer, more precious. The kind of moment that a civilization, if it is paying attention, holds on to even when everything around it changes. Even when the machines that created it have been cut up and melted down and forgotten by everyone except the people who cannot quite bring themselves to let go. Those people are still out there. They are measuring, drawing, manufacturing, waiting for the day when the most beautiful locomotive ever built rolls back onto the rails. And the question that has been waiting 70 years for an answer finally gets one. And the sound it makes when it does, that four-cylinder bark, that mechanical signature unlike anything else that has ever moved on steel, will carry across whatever valley it passes through with the weight of everything that was built and lost and almost recovered. Everything that human beings are capable of when they decide that the impossible is simply a problem that has not been solved yet. That sound will be worth hearing, even if you have to wait a very long time for it.